and we're going to return out a number. Now, of course, if you're pretty familiar with some of the new syntax, the new goodness on TypeScript, you can return, what's it called? Value. Let's see, you can do value or 0 multiplied by 5. So that makes sense. So if value is not undefined, it will be a value, else it will be 0. Multiply 0 by 5, it's still 0. We have fulfilled our beautiful interface. Look at that. We have some nice code for it. I assume everyone else probably arrived to a very similar conclusion, hopefully. All right, so let's do the same thing, but let's do it in Rust. And I'll give you a little bit more time to kind of try this on your own. I'm going to kind of fly a little bit faster through the TypeScript stuff because I'm just going to assume everybody pretty much knows it. Let's do the exact same thing. A signature that takes in a number or undefined, so that means option bracket usize. So it's going to look something like, I'll kind of help you out here. Let me just do that. So let's go function. We'll call it multiply this time. It's going to take in a number that is an option, say usize, and returns back out a usize. So when I first started out doing Rust, I probably would do something like this. If number is sum, because it has a value, I'm going to return num unwrap multiplied by 5. Else I will return 0. GNU parallel? Dude, this was probably what I would write at first, right? Because I just didn't know how to use any of the constructs. Then you get a little bit better, a little bit smarter, and you'll probably do something like if, let, sum, x equals num. And so now I can go x times 5 and do this. Better, right? I'm using pattern matching. I'm solving my problems. But they're still better. Now remember, you can implement methods on enums. So let's go here and go num unwrap. But look at that. Look at all the other ones that are going on there too. Unwrap or. So I can say, hey, unwrap or 0 times 5. Give me that inner value or a default value. The default value has to be of the same type. So that's pretty cool. Like, that's very readable to me. I would argue that that is much more readable than something like that. Less symbols, more words. For me, always a good move. I like that.
You prefer macOS, so I'm looking at the Rust book. I'll scroll down here to the Linux and macOS section. I'm running Ubuntu, but if you're running macOS, this will work as well. All you have to do is copy this text, paste it into your terminal, hit enter, And there you have it. You should see this text, Rust is installed. Now, if you're on Windows, the installation steps are a little bit different, but you can go to the book and it should be fairly simple. To install as well. Rust is now installed, but we also want to install a Rust language server. So if you want things like code completion, Go to definition, and refactoring abilities, this is something you're going to want to install. I happen to be using Visual Studio Code. If you're using the same thing, then you can click the Extensions tab, type in Rust, and the first thing you'll see is the official Rust programming language extension. This is going to be deprecated. So go to the second one, which is called Rust-Analyzer, and install this one. Now the next step is to actually write a Hello World program. So what I'm going to do is I'm going to create a new directory called Hello World. And I'll cd into it. Then open it in VS Code. Now in this Hello World directory, I'm going to create a new file called main.rs. You might get this pop-up here that says the language server for Rust is not yet installed, so go ahead and download that. If you get prompted. You might see this Rust Analyzer failed to discover workspace error, and this is just because we're not using cargo at the moment, so you can ignore that. Alright, so now let's actually write our first Rust program. So we're going to type in fn main. This is the main function that will execute when your program starts, and then we're going to do print line. This is a macro, which we'll learn about later, and you can type in whatever you want. Usually you'll do hello world, but I'm just going to do let's get rusty. Don't forget the semicolon. Save your work. And then we're going to go over to our terminal and type in rust c main.rs to actually compile the program. program. Okay, so Rust C wasn't able to be found because after installing Rust, I didn't reload my terminal, so the paths weren't updated. I opened up a new terminal here. Now it should work, so let's do the same thing. Rust C main.rs. Great, it compiled. You can see here that we have a new main executable, and now I'm just going to run that executable. Great, you've written your first program in Rust. Now you can update your resume and start applying for jobs. I'm just kidding, there are no jobs in Rust. We'll get there though, we'll get there. Okay, so having one main.rs file works great for our little Hello World program, but in the real world, we're gonna have projects with multiple files with dependencies, and we need something to handle that. Luckily, Rust comes with a build system and package manager called Cargo. Now this is a pain point with other low-level programming languages, but luckily for us, Rust just has it built in. So let's check that we have Cargo installed. To do that, you can simply go to your terminal and type in cargo -- version. Okay, great. We see that we have version 1.49.0 installed. Now let's create a Hello World project using Cargo. To do that, we'll type in cargo, new, and then hello_cargo. Okay, great. Cargo has created a new package for us, which we could see in VS Code. Point simply 0.0 installed. Now let's create a Hello World project using Cargo. To do that, we'll type in cargo, new, and then hello_cargo. Okay, great. Cargo has created a new package for us, which we could see in VS Code. Now it has a few different things. First, we have cargo.toml. This is the configuration file for our package. And you can see we have some information such as the name, version, and so forth. And then we have this section for dependencies. Currently, we don't have any dependencies, but if we did, they would be listed here. If you're coming from the web world, this is essentially package.json. We also have gitignore, and that's because Cargo automatically initializes a Git repo for our project. Now you could use a different source control system by specifying it when you're creating a new project, but by default we get a Git repository. And then finally we have this source folder which contains our actual code. You can see a main.rs file was automatically generated for us with the Hello World program. Alright, now let's actually build our Cargo project. I'll cd into our new Hello Cargo directory, and instead of running Rust C, we're going to run cargo build. Now this produced a new file called cargo.lock. That is a file that specifies our exact dependencies. It's sparse right now because we don't have any, but we also have this target directory, which includes this debug directory, which has our actual executable, along with a bunch of other stuff. Now, in order to run our program, all we have to do is go cargo run. And you can see here, hello world is printed. There are also a bunch of other commands. You can go cargo -- help to see them. One useful one is cargo check, which will check your program for errors without actually producing an executable, and you might want to do this because it's a lot faster than running the program. And there you have it, chapter 1 of the Rust book complete. If you like this video, make sure to hit the like button, and if you want to follow the series, subscribe and hit the notification bell so you can get notified when the next video comes out on chapter 2. I'll see you. Welcome back to Let's Get Rusty. My name is Bogdan, and this channel is all about the Rust Rust programming language. If that sounds appealing to you, make sure to hover over that subscribe button and give it a nice little poke. Last time we went through chapter 1 of the Rust Lang book, in which we created a Hello World program. If you haven't checked out that video already, make sure to do so. In this video, we're going through chapter 2 of the book, in which we'll create a fully functional AAA rated guessing game. We're also going to add something special to our game that's not in the book, so make sure to stick around till the end of the video. And with that, let's get started. Okay, now the first thing we actually need to do is create our cargo project. So we'll go into our terminal, type in cargo new guessing game. Then we'll cd into that directory and open it in VS Code. As you can see, we have our standard Hello World program. We could type in cargo run here to make sure it works, but if you have the language server installed, VS Code gives you this neat little button here, which will run the program as well. Now we can start writing our guessing game. The first thing we want to do is change this print statement of Hello World into a print statement that prompts our users to input a number. Now that we have a prompt, let's actually capture the input from the user. So the first thing we're going to want to do is create a variable to store the user's input. And in Rust, we do that by using the let keyword. So I'll go ahead and create a variable called guess, and we'll set that equal to a string. Now here we have string, which is a type in Rust standard library, and it's a UTF-8 encoded growable string. If that doesn't make much sense, we'll go more in depth into strings in later chapters. Then we have this : new syntax. New is a function on the string type, and it's an associated function. Other languages call these static methods, but essentially it's the same thing. And then new returns an empty string that we could use. Now notice Rust is also smart enough to realize that our variable guess is of type string without us actually having to annotate it, and that's because Rust knows that this new function returns a string. One last thing here, in Rust, variables are immutable by default, but we know we want to change guess because we want to capture the user's input and store that in guess. So to make it mutable, we'll use the mute keyword here. Now that we have our variable set up, let's actually take in the user's input. To do that, we'll need to bring a library called IO into scope. To bring the IO library into scope, we simply type use std for the standard library : IO. Okay, now let's actually use the IO library. To do that, we'll type in IO : std in. stdin will give us a handle to the standard input of the current process. Readline will take in the user's input and append it to the specified buffer, which in this case is our guess string. Notice also that this function takes a mutable reference to string. We'll learn about references in later chapters, but this is essentially saying that it'll take a reference to string, modify it without taking ownership of the string. So we'll go ahead and pass in a mutable reference to guess. Readline returns a result type, and let me pull up the documentation here. The result type is an enumeration that can either return the variant OK, which will hold our return value, or error, which will hold an error object. And this is great because this forces us to handle the error case. In this instance, we know that if an error is returned, it's probably a system error, so we'll use the expect function here. And as you can see, if the OK variant is returned, then expect will just return the value contained in OK. Otherwise, it will panic with the message provided. In this case, our message would simply be